Welcome to Fascinating Frontiers, episode 113, coming to you on June 26, 2026. Let's look at what's new across the frontiers of space and science. After 8 years of continuous thrust, BepiColombo has powered down its engines for the final coast toward Mercury. The ESA, a JAXA spacecraft, has switched off its solar electric propulsion system after operating it for 8 years across the inner solar system. The mission now begins its final approach sequence, with critical arrival maneuvers scheduled to start in September. The blue glow from the engines marked one of the longest continuous uses of ion propulsion on a planetary mission. Engineers will rely on chemical thrusters and gravity assists for the remaining trajectory adjustments. The next milestone watchers are tracking is the September start of the arrival phase. Residual xenon propellant levels will determine whether any extended operations are possible beyond the primary mission. BepiColombo's decision to shut down its ion engines marks the transition from cruise to arrival operations at Mercury. The solar electric system provided the gentle, continuous thrust needed to reach the innermost planet despite limited launch mass. With the engines off, the spacecraft will rely on a series of gravity-assist flybys and short chemical burns to enter orbit. The long propulsion phase demonstrated how electric systems can stretch the reach of modest launch vehicles. What remains unclear is how much residual xenon propellant will be left for any extended mission operations once the primary science phase begins. If the chemical rockets that lifted BepiColombo from Earth had to carry all the propellant needed for the entire trip, the spacecraft would have been impossibly heavy. Instead, its ion engines sipped xenon and accelerated to 40 kilometers per second, producing a thrust measured in millinewtons yet sustained for years. Over 8 years, the cumulative velocity change reached tens of kilometers per second while consuming only a few hundred kilograms of fuel. The journey itself becomes a slow spiral inward, trading time for mass efficiency in a way chemical stages cannot match. The unanswered question is how far this gentle push can be scaled before power limits or thruster lifetime become the next barrier. Now, shifting focus to another terrestrial world. Researchers at the University of Oxford have identified signs of enormous, Earth-like magmatic systems that once existed deep beneath the Martian surface. The findings challenge the long-held view that plate tectonics are required for such complex geology. Data from orbital instruments revealed layered structures consistent with repeated episodes of large-scale melting and intrusion. These hidden systems would have shaped the planet's crust and mantle over billions of years. Follow-up studies will examine whether similar features appear in other regions of Mars. On a different note, interior models for the ice giants are also being revisited. New interior models suggest the two outer planets could host hot, rocky magma layers rather than the traditional water-ammonia ices. Voyager 2 flyby data from 1986 and 1989 remain the only direct measurements, leaving room for alternative compositions. Revised equations of state show that silicate mantles under high pressure and temperature could match the observed densities and magnetic fields. The shift would change how scientists interpret heat flow and atmospheric dynamics on both worlds. Future orbiter missions will test these predictions through gravity and magnetic measurements. Next up, a high-resolution view of our own galaxy's center. The ESA telescope spent 26 hours collecting a high-resolution image of the crowded stellar field near the galactic center. Although this observation falls outside the mission's primary cosmology program, the data will support gravitational microlensing searches planned for NASA's Roman Space Telescope. The image reveals millions of stars packed into a region only a few degrees across. Processing the crowded field required new algorithms to separate overlapping sources. Astronomers expect the catalog to aid studies of stellar populations and dark matter distribution in the inner galaxy. Turning now to dynamics within the solar system itself. Gaia data allowed researchers to trace a star that passed close enough to disturb the Oort cloud several million years ago. The gravitational perturbation is thought to have increased the number of comets sent toward the inner solar system. Nathan Kaib of the Planetary Science Institute and Sean Raymond of Université de Bordeaux presented the work at the American Astronomical Society Division on Dynamical Astronomy meeting. Models show some of those altered orbits could still be delivering comets today. Continued monitoring of new long-period comets will help test the connection. Hubble has captured another early universe object in action. The galaxy, observed as it appeared 1.4 billion years after the Big Bang, is emitting intense ultraviolet radiation, capable of ionizing surrounding hydrogen. Hubble's ultraviolet sensitivity captured the object during its brief window of activity. This detection supports the idea that small, starburst galaxies contributed significantly to reionization. The galaxy's compact size and high star formation rate make it an efficient source of ionizing photons. Additional observations with JWST are planned to measure its exact contribution to clearing the intergalactic medium. Commercial weather data collection is also advancing. The GEMS-2 Amethyst satellite, launched March 30 on a SpaceX transporter mission, has begun returning global atmospheric data. Its microwave radiometer measures temperature and moisture profiles through clouds. Early imagery confirms the instrument is meeting performance expectations for weather forecasting applications. The Boulder-based company plans to expand the constellation with additional satellites. Data validation against ground stations is the next step before operational use. Shifting to military communications infrastructure. The next generation Mobile User Objective System satellites will ride on Boeing's 702 MP spacecraft bus. The platform has already supported both commercial and wideband military communications missions. The contract covers construction of satellites designed to provide secure voice and data links for mobile forces. Integration of the 702 MP's electric propulsion and high-power payload capabilities is underway. Launch dates for the first satellites have not yet been announced. Rocket Lab continues its launch cadence for dedicated customers. The Electron rocket is scheduled to lift off from New Zealand today, carrying the latest synthetic aperture radar satellite for the Japanese company. This mission continues Synspective's effort to build a constellation for all-weather Earth imaging. The payload will join earlier satellites already operating in orbit. Rocket Lab has flown multiple dedicated missions for the customer under a multi-launch agreement. Weather and range checks are the final items before liftoff. NASA has selected the same provider for 2 new science missions. Rocket Lab will provide launch services for the Pulsar Ice Cloud Radiometer mission and the TSIS-2 Solar Irradiance Sensor under the VADR contract. Both payloads will fly on separate Electron vehicles. Pulsar will study polarized submillimeter radiation from ice clouds, while TSIS-2 continues long-term solar monitoring. The selections mark another step in NASA's use of small launch providers for dedicated science missions. Mission integration schedules are now being finalized. Earth observation satellites are tracking current heat extremes. The satellite recorded land surface temperatures on June 23, showing values well above seasonal norms in France, Spain, and Italy. Madrid reached 48 degrees Celsius, Poitiers 46 degrees Celsius, and Rome 44 degrees Celsius in the late morning. The infrared measurements provide a consistent view across urban and rural areas. Copernicus services are using the data to assess heat stress impacts on populations and agriculture. Additional passes are scheduled as the heat wave continues. Agricultural expansion in arid zones is visible from orbit as well. New images reveal irrigated fields appearing in the desert near the Sudan border. The Copernicus satellite captured the contrast between green cropland and surrounding sand. Farmers are drawing on groundwater to support the expansion. The time series from Sentinel-2 allows monitoring of field growth and water use patterns. Similar developments are being tracked in other arid regions. Astronauts and cosmonauts representing Crew 10, Soyuz MS-27, and Crew 11 met at Space Center Houston on June 16. They spoke about eye exams, DNA sequencing of microbes, and spacesuit preparations from their time on the station. Ground teams were thanked for supporting the research and maintenance tasks. Daily exercise routines and virtual reality studies were described as part of the broader science program. Video recordings from the discussion are accessible via NASA's Johnson Space Center channels. A memorandum of agreement between NASA and the SBA is set for signing on June 29 at NASA headquarters. The goal is to assist small businesses in competing for space-related contracts aligned with national space policy. Outreach and technical assistance programs will be coordinated by the two agencies. Focus areas include reducing obstacles for firms working on hardware and services tied to NASA missions. First joint activities will have details shared following the signing ceremony. Mercury can be seen approaching Jupiter low in the western sky after sunset. Its brightness continues to fade while moving past greatest elongation. Magnitude 1.4 is recorded for Mercury on June 26. Visibility of the pair will last several more evenings until Mercury gets too near the horizon. Binoculars assist in distinguishing the planets amid the twilight. Before we go, keep an eye on the next round of Sentinel-3 passes as the European heat wave continues. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network, links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Models and Agents, your daily briefing on AI models and agents. Find every show free at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through